And this is Ken Rosever. In Alex, you're going to have some problems that are in Chapter 2. You're going to be asked to create frequency polygons for grouped data. Frequency polygons in your book are discussed on page 53. And there's 4 steps to doing this. Um, let's follow these instructions though. They say draw the frequency polygon for these data using an initial class boundary of 2.5 and a class width of 2. So our initial class boundary is 2.5. Now a lot of students make the mistake of taking 2.5 and initially writing it down there. They put a 2.5 and then because it says a class width of 2, they put a 4.5, a 6.5, a 8.5, but that's wrong. Let's write it up here. 2.5. And you're right about the 4.5 and the 6.5 and 8.5 and stuff like that. That is part of the process, but we're not there yet. So let me pause for a second with that and come back to it. Um, look at these values. You have numbers between 3 and 13. You have a class width of 2. So you're going to have a few classes. Now, a lot of students make the mistake of going, okay, 3 is going to be in there. And they think lowest number is 3, class width is 2, so 3 to 5 is going to be my first class. No, not if your class width is 2. That's actually a class width of 3. It's kind of maybe difficult to see there, but 3, for our intents and purposes, has a boundary at 2.5 because anything higher than 2.5, don't we round it up to 3? And doesn't 5 kind of end at 5.5? Because anything less than 5.5, we round down to 5. So if you look at 5.5 to 2.5, you'll see there's actually a difference of 3 there, not a difference of 2. You can't just go 3 plus 2 is 5 and put a dash and think that is your first class. No, that's not it at all. What we have to do is understand that the class width is from the beginning of this class boundary to the beginning of the next class's boundary. So it's a distance of 2. So the next class begins at 4.5, which means it actually goes 2.5 up to 4.5. So it encompasses the numbers 3 and 4. 3 to 4 are in here if we're dealing just with integers. Okay, these are the class boundaries. The class width is 2. And these are the actual, like if we were to put labels on a histogram, we would put labels that say 3 to 4 on the bar. If we were doing a bar graph instead of we put 3 to 4, 5 to 6, 7 to 8. Those would be our class labels. Um, let's go back to this. So now we have 4.5. 4.5 to what? 6.5. And then we keep skipping up by 2, 8.5, 10.5. And how high do we have to go? We have to go high enough so that we have room in our classes for each one of these guys. So I got to be able to fit a 13 in there, and the lowest number is a 3. 3 is going to fit in the first class. That's where it belongs. But 13 doesn't fit there yet because we know 10.5 ends at 12.5 and 12.5 ends at 14.5. So I don't really have to do all these on this side because I know that these just repeat over here. But this might help us the first time. So 4.5 to 6.5 is class 2, 6.5 to 8.5 is class 3, 8.5 to 10.5. But really, do we see any decimals here? No, we do not. So we can actually think of it as being class 2 is actually 5 to 6, 7 to 8, 9 to 10, 11 to 12, 13 to 14. And now that we've defined our classes, we need to count how many are in each class. So in the 3 to 4 class, or the 2.5 to 4.5, in the 3 to 4 we have 1, we have 2, 3, 4. So there's 4 in there. In the next class, 5 to 6, we have 1, 2, 3, 3 in there. In the 7 to 8 class, we have 1, 2, 3, 4. In the 9 to 10 class, 1, 2, 3. We have 3 again. 4, 3, 4, 3. In this one, we have, I think it's 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. And then in the last class, we have 1, 13. If you add all these up real quick, you'll see 4 plus 3 plus 4 is 14, plus 9 is 23. So that agrees with that, and we're happy. Now what we have to do is in Alex, we'd actually, and I closed out the screen on mistake. This is down here is the next problem that I'm going to demonstrate. But we would actually take these values and we would drag up this dot up to the 4. We would drag this next class up to the 3. When we run out of classes, we would hit this button here to add more classes. If we put in an extra class on mistake, we'd use this button here to remove a class. So we'd do that. We'd use this little handy symbol to grab this button and move it up. But before we could do that, we would have to label the classes. Now I said with a histogram, you would use these labels. You can't do that on a frequency polygon. The rule on a frequency polygon says we use the midpoint of the class. So the midpoint of 3 to 4 or the midpoint of 2 to 4.5 is the same. How is it found? Add the class boundaries and divide by 2, or add the 3 and the 4 and divide by 2. It doesn't matter. Or just think, what's the number directly in the middle of 3 and 4? Or between 2.5 and 4.5? It's 3.5. So this midpoint is 3.5. This one is 5.5. And you can see 3.5, 5.5, 7.5. Those also skip by 2. So 3.5, 5.5, 7.5, 9.5. And we'd have to hit this button twice because we'd need an 11.5 and a 13.5. Having hit that twice, we would then drag these up until we had this point here, 4. Then this point would be a 3, a 4, 3, 8, and a 1. Let me just go like this. And then we'd connect. And it would actually connect these for us in Alex. And we get something that looks like this. And that would be our frequency polygon. Okay. Having done that, let me give you another example. Okay. And this one we'll actually do into Alex so you can see how it's done. It's on the next page. You can see I already started doing some work here. I'm going to do the exact same thing, but see if you guys can do it on your own. Now, the information's a little different, but I think you can handle it. I'm going to pause, do a bunch of work, and come back and explain it. All right, first thing. They tell us to draw the frequency polygon for these data using initial class boundary of 22.5. Don't stick a 22.5 down there, that's wrong. Ending class boundary of 50.5. Don't stick a 50.5 down there, even though, yes, we're going to have 4 classes of equal width, so we're not going to have to add any classes. What you need to do is think this is the highest number possible, and this is the lowest number possible to be represented in this frequency polygon. Of course, we're not going to represent either of those because they're not in the list, but all the same, 22.5, 50.5, that's the range. What I'm going to do is I'm going to subtract these two and I get 28. 28 I'm going to divide into 4 equal width, equal, equal classes. So that gives me the class width is 7. Now, that means I'm going to have 22.5 to 29.5. I'm going to have 29.5 to 37.5. Whoops, 36.5. And I filled in all the rest. Okay, you can see with me that these still skip by 7. But when we get to here, we don't add a 7 again because we're only going for 4. And this one ends at 50.5. You can see there's no numbers higher than 50.5, so we don't have to bother. What I'm going to do is count now. Okay, I counted, and in the 23 to 29 class, that's this one, I had 2, then I had 1, then I had 10, then I had 1. I'm going to plot that on the next page. Here we go. I had 2, I had 1, I had 10, oh, that's 9, 10. I did 1. The only thing I have left to do is label these classes, and I do that with the midpoints. So, all right, taking the average of these two and dividing, I get 26. If the first one's 26, we can skip by 7 for the next two. And so they are 26, 33, 40, and 47, and we're out of time.